we are going to start this chapter, current electricity. Current electricity. Now, if you are going through this video or any topic in this chapter, then you must be very clear with the idea of potential difference. Okay. If you have doubt over potential difference, what is it? Then you will have doubt in this chapter when we go forward. So if you have doubt, please go back and see the potential difference videos. I mean, there are prerequisite. There are certain concepts that you are should be very clear about. You should be clear about electric field. You should be clear about that the positive charge move in the direction of the field, negative charge move about opposite to the direction of fields. These things should be clear. Then again, if there is electric field, there must be some potential difference that must exist between the points. If this point has a potential VA, this point has a potential VB, so there must be some potential difference between this VA, VB, okay, or else the electric field will not exist, the charge won't move, and so on. So if you're not clear with these concepts, go back and see the videos on the previous chapter, then only move on with this chapter, or else you'll still have doubt. So current electricity is one of the large chapter in the second year syllabus. So first, what is current? The study, what is current? So the study of electric charge in motion is current electricity, as the study of charges at rest was electrostatics. So current electricity is also known as, it's also known as electrodynamics. Sometimes current electricity is also known as electrodynamics. Because study of charge in motion. Now we go back to the basics first. Why do the charge move? Why does a charge will move? It will only move when there is an electric field. And if there is an electric field, that means there must exist a potential difference, VAVB. Now, if there is a potential difference, the charges are going to move. This will create a flow of charge. Okay, this must create a flow of charge. So if the two bodies charged to different potential are connected together by a mean of conducting wire. So if you want the charge to flow, you must also provide a conducting medium in between, isn't it? If you want this charge to flow, you must provide a conducting medium. If you keep an insulating medium, obviously the charge is not going to flow. If you keep insulators, charge is not going to flow. So conducting medium, two bodies charged to different potential are connected together by the means of conducting wire. Charge begins to flow from one body to another, and charge continues to flow till the potential of the two bodies become equal. This is very important. So charge will continue to flow till the two bodies we have. So let's say the body 1 VA having a potential VA, body 2 having a potential VB. You connected them by a conductor, and the charges are going to flow. Okay, the charges are going to flow till VA and VB both become same. When they both become same, the charge will stop flowing. Okay, then stop flowing. Very simple. So what would be electric current? Okay, what would be electric current? The formal definition. The flow of electric charge through a conductor. The flow of electric charge through a conductor constitute an electric current. And quantitatively, electric current in a conductor across an area held perpendicular to the direction of the flow of charge. First, let us understand this. What is this area held perpendicular means? So consider this as a conductor, and obviously there is a potential difference across the conductor. And due to this potential difference, some charges are flowing. Now within the conductor there is a area, there is some cross section area, okay, and the charges are flowing like this. So you can very well see that this cross section area is perpendicular, okay, to the flow of charge. So The electric current in conductor across the area held perpendicular to the direction of the flow of charge is defined as the amount of charge flowing across that area per unit time. So first you must have one area, that you should define an area through which the current is flowing, and the amount of charge that is flowing, that will be the current, the amount of charge which is flowing under a unit time across this area per unit time. So Q by T will become I. This is the standard definition in area held. Now if you think other way, you can you can imagine, let's say this is another conductor, and within this conductor, if you have you have decided that, let's say this be our area. Now this area, you see, is this area is in the direction of the flow of charge. If the charges are flowing like this, so this area is in the direction of flow of the charge itself. So that would means that there is no current. You see, there is no current from this area, because the very definition of current will have this particular idea that the area held perpendicular. So you must have a particular area defined through which you are calculating current. This type of concept is not required for a PU level exam or any NEET level exam, but JEE advanced level, if you are moving to JEE advanced level, then you will have such questions where current needs to be calculated for a specific area. Okay, so that is our current. Now what is the formula and unit? What will be the current? So electric current would become electric charge over time, Q by T. Okay, electric charge over time. Now you see current. So lightning is also a current. Lightning, which is a flow of the electric charge between the two clouds. You know this. Now lightning is a very large amount of current, but for a short time. So this is called a transient current, a current which is of very large value, but for a short time. Basically, current of in a very short time duration is very short. But this is not how your home electricity works. Home electricity works in the with an idea of steady charge flow in steady manner. That means the charges are flowing steadily, and that is why you can see your your fans and lights and all this all this DC voltage devices works. Okay, torch, hearing aid, because a steady flow of charge is required to run these devices. So these are steadily flow of charge that works on. But this large amount of current flowing in small time will be the transient current. Unit of current is ampere. The SI unit of current is 1 ampere, and 1 ampere would become 1 coulomb over 1 second, because current I is equal to Q by T. So unit of charge is coulomb, unit of time is second. Now how many electrons makes 1 coulomb? This you have done in the first chapter. Remember how many electrons makes 1 coulomb? This answer was 6.25 10 raised to 18 numbers of electron make 1 coulomb. Okay, remember that. That means if you say that 1 ampere of current, let's say if in a given situation 1 ampere of current, if you say, that would means 1 coulomb of charge flowing through a conducting wire, 1 coulomb of charge flowing through conducting wire in 1 second. And that would mean 6.25 into 10 raised to 18 numbers of electron. This numbers of electron flowing through the conductor in 1 second. You have many devices in your home appliances. You can find what is the current flowing through the appliance. There is always specified. You're using any electronic device also, you can find the amount of current. So, and then if you know the value of current, you can then also find the value of electron, the number of electron that is flowing per second. Now current have different values. That depends upon what kind of application it is. So microampere, milliamperes, all these values. and domestic appliances in the range of 1 ampere, lightning 10 raised to 4 ampere, inner nerves 10 raised to minus 6 ampere. So you have current are different values. Then we come to conventional current and electronic current. This is not a very serious, important topic. It is very simple that the direction of the current is taken as opposite to the direction of flow of electron. Okay, the direction of the current is taken opposite to the flow of electrons. So if the electrons, look very closely, if the electrons, negative charge or electrons, they are moving in this direction, so the current is considered to be going in the opposite direction. Okay, that's what conventional electronic current is. So don't take it very easy, because conventional current is not such an SI unit or value or something. It's not very important. Then again, one of the property of current is that current is a scalar. It is a scalar. So scalar quantity means it doesn't have any direction, and you can very simply add the current like a scalar values. Now we have understood, till now we have understood that if there is a potential difference, that will cause an electric field, and if there is an electric field, then charges would flow. Okay, and when the charges flow, then how much charges is flowing, that is rate of flow of charge. You see, the rate of flow of charge, we have understood that this rate of flow of charge, this value here, this is the current. We have understood this is current. That means the current that is at the rate of flow of charge, how much charge is flowing, how much Q charge is flowing per unit time, that also depends upon the potential difference. And this you have done in your junior class as well. This is what's Ohm's law. This is what is Ohm's law. You have done in your junior classes that the current flowing in a circuit is proportional to the potential difference. Current and potential difference is directly proportional. That is, if you have greater potential difference, then there will be stronger electric field. If you have a stronger electric field, then more charges are going to flow per unit time, and that would create more current. That's why both of them are proportional to each other. Now, if they are proportional to each other, then there would be a constant here, and this constant here is the resistance. This also is been taught to you in your previous classes. So what would be the formal definition of Ohm's law? Current flowing through the conductor is directly proportional to the potential difference applied across its end, provided the temperature and the other physical condition remains unchanged. So look here, in the definition, you will not find the word resistance. You will not find the word resistance, because it is only said that what potential is proportional to current and resistance is one of the constant. There is a constant which we say this is resistant, but there can be some other constant as well. This you are going to learn in the chapter alternating current, that current and voltage are proportional, but there can be other constant as XC and omega and all. You will learn this in AC, alternating current. So they are only proportional to each other, and provided the current, the temperature must remain constant. This must not change. So if you're going to draw a graph of current and voltage, how does the graph looks like? So first understand the value of the graph here and here, like which value should you put on the X and Y. Now there is a bit of confusion. See, you start with the Ohm's law, that is V is equal to IR, and then your R becomes V over I. That means change in the V by change in I. Now, if you think in this way and put the value of V, put the value of V on the y-axis, let's say you put the value of V here and the value of I here, then this line, the slope would become resistance. But mathematically, we always try to put the value x-axis value as independent variable. Independent variable. You have done this in your junior classes. X-axis पे generally independent variables are put and y-axis पे dependent variable. And here we know that potential is the independent variable and this is a dependent variable. We will be discussing it. If you don't know this, then we will discuss this idea in this chapter, in the next chapter also, that this potential is an independent variable. It is very simple to understand. You see, 220 volt of current is 220 volt of potential difference is given to your house by the power company wherever you are living. But that 220 volt is also given to others. Your neighbors are also getting the same 220. You see, everybody gets the same. That means if you go and buy a ever-ready battery 1.5 volt, every ever-ready battery has the same potential. So potential is an independent, it's a fixed value that you are going to get. The current depends upon the potential. What you use in your home is current. Potential is given to every home, the same potential difference is given. So like that, potential has to be put in this and then current will come here, and the slope of this line, will then become 1 by R, not R. Okay, so be very careful whenever you solve a numerical involving the graph of current voltage. Be very clear first that how the graph is plotted, IV or VI. Different books have different numericals where both the graphs are given and students get confused about it. Now, what would be resistance? So resistance of a conductor is a property, okay, is by the virtue of which it opposes the flow of charges through it. The more resistance, the less the current I. Okay, that means if you have a conductor, the resistance try to stop the current from flowing. Okay, resistance try to, I mean, it doesn't stop actually, but it kind of resists it. So the charges are flowing, the resistance is going to cause the charges to lose their energy while they are moving through. It will allow, obviously, resistance does not mean it will stop. Okay, it does not mean it stop the charges from flowing. It will allow the charges to flow. Now, the more resistance, the less is current. Very simple. If resistance is very high, current will be less. High resistance would mean it will allow less amount of charge to flow per unit time and so on. So it is equal to the ratio of the potential difference applied across the conductor to the current flowing through it. Very simple. R is equal to V over I. SI unit of resistance is ohms, OHMs, with a symbol this. If the potential difference V is 1 volt, current is 1 ampere, then the resistance will be 1 ohms. Very simple definition, formula. Resistance of the conductor is said to be 1 ohms if a current of 1 ampere flowing through it on applying a potential difference of 1 volt across it. So this is the standard formula and definition. Now, again, any device has a certain resistance or opposition to the flow of current. So any material that has some resistance is called resistor. Okay, any material that has resistance is called resistor. There are different diagrams for resistance, that is the different symbol. So you have a fixed resistance and variable resistance. Very simple. This is how a fixed resistance looks like. This would be a variable resistance. Okay, and this is a potential divider. Now, if you don't know what a potential divider is, we will be doing this in the this chapter itself. Okay, you'll come across it, but you should know because it is discussed in class 10 syllabus. Potential divider. So this is a symbol. So what are the factor affecting the resistance? What will be the factor affecting resistance? So resistance is proportional to, first the resistance is proportional to three factors. So at a constant temperature, so this is proportional to these three factors, but there is a condition here at a constant temperature. The resistance of the conductor depend upon the following factor. Length, so resistance will be proportional to length. Longer the wire, more will be the resistance. Very simple. Then inversely proportional to area. What is this inversely proportional to area? So thicker wire, thicker means more width, so we'll have less resistance, and thinner wires will have more resistance. Okay, more resistance and less resistance. Very simple. The third thing is the nature of the material. You see, every material is not same. Their atomic level things are different. So how does the flow of charge in a certain material is going to be? That depend upon the atomic and the molecular structure of the material. Some material will become a very high resistance, like nichrome wire has 60 times copper wire, and some will be less. Copper again is less, some again a better, they are better conductors. Less resistance means good conductors. Now combining these three, you will get the value of resistance in the terms of length, area, and this value here, resistivity or specific resistance. So if you consider a unit length wire, let's say this conductor of unit length, okay, unit length conductor, let's say 1 meter unit length conductor, and unit cross section area 1 meter square. So unit area and unit length, if you consider, then resistance is equal to the resistivity. This term here, this symbol here is called rho, and this is called resistivity. So resistivity or specific resistance. Specific resistance is the same thing, resistivity. Specific resistance of the material may be defined as a resistance of the conductor of that material having unit length and unit cross section area, or resistance offered by unit cube of the material of the conductor. So why unit cube? Because if you take this as 1 meter and this as 1